In this video, we're going to start our talk about linear inequalities. There'll be a few videos for this one. We're going to talk about the part 1 in this one. Let's first talk about the difference between an equation and an inequality. So far in class, we've been talking about linear equations. A linear equation can have one solution, no solution, or a solution of all real numbers, where the symbol for an equation would just be the equal sign. However, a linear inequality will have a set of solutions which could be all real numbers or it will be no solution. The symbols for an inequality will be less than, greater than, less than or equal to, or greater than or equal to. Now there are two types of linear inequalities we're going to talk about, one variable and two variable. In this video, we're going to discuss one variable linear inequalities. One variable linear inequality simply is an inequality with one variable. For example, 2x plus 4 is less than 5. We have one variable, and the exponent of that is 1, so therefore we have a one variable linear inequality. Now the solution to this inequality is going to be a set of numbers, but it can be visualized or seen in three different ways: set notation, graphing, and interval notation. Set notation, as we've seen before, would be some sort of set that fits the ordered pairs, so we'd say x element of the real numbers, such that, and then there'll be some sort of rule here based on what this inequality is. We can then also graph by drawing a number line, and whatever that solution may be, whatever this cutoff is, let's say that's c, let's say x is less than c, whatever c is, then if I graph that, I then graph all the numbers that are less than that. Interval notation is the one that you may not be familiar with. We're going to go a little more of a deep dive into interval notation. Interval notation is a way to write a range of numbers using parentheses, brackets, or a combination of both. Intervals are written with a lower bound and then with the upper bound. An example of this would be the interval AB. A and B are numbers where A is going to be less than B, strictly less than B. The value of A is considered the lower bound, and the value of B is considered the upper bound. We can also call values A and B our endpoints. These are where our interval begins and where our interval ends. The symbols used for interval notation states whether endpoints are part of the interval. So remember how in the beginning it said we were using parentheses, brackets, or a combination of both. Parentheses will determine, and brackets determine whether we include or exclude endpoints. If we have a parenthesis where both parentheses are on both sides of the interval, we exclude the endpoints. This will correspond to any inequality that is strictly less than or strictly greater than. If we have brackets on both ends of our interval, this will mean we include the endpoints, and it will correspond with less than or equal to or greater than or equal to. We could also have a combination. We could have one endpoint being included and the other one excluded. Remember that the parenthesis is inclusion, or the parenthesis is exclusion, while the bracket is inclusion. If we, for example, had the inequality of 8 less than x less than or equal to 15, this would be corresponding to the interval of parenthesis 8, 15 bracket, where the parenthesis says it's open or excluded. We'd exclude 8, but we're going to include 15. So we can get a number really close to 8, but 8 will not be part of our solution, but we can include 15. Excuse me. Next slide. Let's look at a visualization of each of the solutions. Let's suppose that our inequality is x is greater than 0. In set notation, that would be the set S such that x is x is going to be greater than 0. And then we have the interval notation of 0 to infinity. 0 is where we start the interval, and where we end is infinity. In other words, we don't end at all, we just keep going. And then the graph would be as such. We have the 0 here, which is where the interval starts. And then we go on towards infinity, which is why we have the arrow put here. You'll also see at 0 we have an open circle. That's because we're not including 0 in our solution. So a parenthesis is the same thing as an open circle, while the bracket is considered as a closed circle. This is something you might be remember from previous courses or classes. But the important thing is that for each representation, it's the same set. The set of S is the same numbers as the interval notation, and it's the same numbers as the graph, which means we can do each type of visualization of the same solution set. Let's practice. Let's solve an inequality, one variable inequality. Let's suppose we have the inequality of 8x minus 5 is greater than or equal to 11. We're going to write the solution in set notation, interval notation, and as a graph. So first thing, I want to get x by itself. Luckily for us, in general, solving a linear inequality is similar to solving a linear equation. I want to get x by itself. So I'm going to go ahead and I'm going to add 5 to both sides. And I'm going to divide by 8. So what I have, oh, that's a 2. Whoop. So now I have this inequality. I'm going to write it as a set. So my set notation is going to be the set S such that x is an element of the real number system. Oops. Make that a little bit better. Set of R such that x is greater than or equal to 2. Now interval notation looks at where's my endpoints and do I include or exclude. Here we see that x is bigger than or equal to 2. That would mean that my lower bound is 2. And because I have equals, it means I'm going to include the lower bound of 2. So I'm going to have a bracket for 2. Now, since the upper bound of x does not exist because we're going towards infinity, we would say that the upper bound goes to infinity. Anytime we have infinity as one of our bounds, it's always parenthesis. Now we're going to go ahead and do our graph. I'm going to draw a line. Now my cutoff is 2, so I'm going to go ahead and put 2 here. We could scale it 3, 4, 5, 1, 0, -1. But now I have to, so on the number line, I have to show the solution here. Since 2 is my lower bound, I'm going to go ahead and mark 2. Because it's included, I'm going to go ahead and create a circle. There we go. Now I have to make sure I'm showing the same numbers. Since we are going greater than we're going towards infinity, I'm going to draw the line with an extra big arrow. And there's my solution. We have done set notation, interval notation, and the graph. We'll do one more. So we're going to solve this inequality now. We're going to do the same thing as we did before. We're going to solve this similarly to an equation. So I'm going to go ahead and distribute the 2. And then we'll have, it's 15. Now here's where it gets tricky. If we divide by a negative number, the orientation of the inequality switches around. Because the negative sign forces it to go the other direction. Because now if I were to multiply x by a positive number, I'm going to have a negative answer. But if I multiply by a larger number, or if I multiply by a positive number, then this overall thing is going to be negative. But if I multiply by a negative number, then this whole thing can be positive, which is what I need to have in order for this to be true. So anytime we have a negative number that we're multiplying or dividing by, we have to flip around the orientation. That's the one big rule between solving equations and inequalities. Now we'll do our set notation. So the set S, where x is an element of the real number system such that x is less than negative 15 over 2. Now we talked about set notation way back at the beginning of the semester. Now let's talk about interval notation. Interval notation, we defined the lower bound and the upper bound. Here, the lower bound of x is actually negative infinity. From the previous one, we know that anything with infinity has to have an open bracket, or open brace, open parenthesis. Now the upper bound is actually negative 15 over 2. Based on the inequality, there is no equals here, which means that my this endpoint is going to be open. It's going to be parenthesis. Now we're going to go ahead and graph. I have negative 15 over 2. Now if I don't scale it, I'm just go ahead and mark 0 over here. And the negative 15 over 2 is the same thing as 7.5. I'm going to go over here and put negative 10 over here. This time, the endpoint is not included because of the open parentheses. So I'm going to put a circle, an open circle, at this. But I am going less. So now I'm going to color this side with a big arrow. And now I've graphed my set. As a reminder, the set listed here and the interval notation and the graph all represent the same set of numbers. Whether you show your solution, whether you present your solution as a set or as an interval or as a graph, we're still giving the same solution for this one inequality.